Today we are going to learn the second part of the relation and function, that is types of functions. So before going to types of function, there is something which you need to understand, that is range, domain and codomain. So suppose consider a function f mapping x to y, where x and y are two sets. We usually represent them in the form of ellipses. Suppose I'll consider the set x as to be 1 2 3 4 and this is 5 6 7 and 8. According to some function, the mapping takes place. The first set or the set which is called the x is nothing but known as domain. The second set is known as codomain. Okay, so the first set is known as domain, second set is known as codomain, and the mapping where it has taken place, where all the mapping it has taken place, that is known as range. So in this case, what is the range? The mapping has been taken over to 5, it has taken over to 6, it has taken to 7 and 8. So it is 5 6 7 and 8. Okay, so this is the very basic introduction of range, domain and codomain. So let's study the types of functions. The first type of function is 1 function. So as it is listed on the board over here, every element in a domain has one and only one image in codomain. Okay, so as studied earlier, what this is, the first set we call it as domain. This is codomain, and suppose you have 1 2 3 and 4 and a b c d. Suppose now what this statement says, every element in a domain, in the sense the first set, every element in domain has one and only one image. It should have one and only one image. So 1 has the image as 2, 3 has the image of b, 2 has the image of d. Okay, so 4 has the image of c. Every element in domain has one and only one image. Only one image it has. No, it has mapped with only one thing. So this is known as 1 type of function. Okay, when we say it is not 1, when you have the set like this, 1 2 3 and 4, a b c d e, and 1 is mapping with a. This is now 1 function. But if even 2 maps with a, it means what? Now this definition failed. Every element in domain has one and only one image. But here every element in domain, or the elements in domain, has only one image. 2 elements in domain have only one image. Therefore this is not a 1 function. Okay, so if your function is of this kind, then this is known as the 1 type of function. The second type of function that we are going to study is onto function or surjective type of function. In this function, what it says is, suppose a function is said to be onto if every element of y has at least one image in some element in x. Okay, so see here, suppose you have two sets like this, x and y. So f is x mapping from y, and suppose x is 1 2 3 and 4, y is a b c and d. Now every element of y should have at least or one image in x. Okay, so 1 is mapping with a, 3 is mapping with b, 2 with this and this with this. Now in onto function, do you see any empty or unmapped elements in codomain? There is no element in codomain which is unmapped. So therefore this is known as, this is codomain, right? This is domain. Do you find any empty or unmapped elements in codomain? No, there is nothing. Okay, so therefore these all are exhausted already. So such function is known as onto function. So now let us see some examples based on 1 and onto, and we'll move further. So as you can see here, every element in the first set, that is domain, has only one image. Therefore this is an 1 function. Now what is the definition of onto? Every element of the second set should be exhausted or should be mapped with one another. But in this case, E and F are idle and they are not mapped with any of the things. So this function is not onto. So the next one, see here, every element of set 1 or set the domain should have only one image, but here 1 and 2 has the single image as B, which makes it a many one function. So therefore this is not a one function. When you check for onto function, every element of set Y should be mapped, but E and F are not mapped, so this is not an onto function also. Moving on to the next one, again the same case as before, but here 1 and 2 has the same image A, so therefore this is not a one function. Checking for onto function definition, every element of second set or set Y should be mapped with any of the things. So it is mapped, so therefore this is an onto function. So the next one, now you can see here every element of the first set has been mapped with individual elements in the set B, so therefore this is an onto one function. And every element of set Y has been exhausted and it is mapped with at least one element in the set X, so therefore this is an onto function as well. Okay, so there is a next type of function that is known as a bijective function. So basically if a function is 1 as well as onto, it is known as a bijective function. Or the second definition also holds good, the function which is injective as well as surjective, it should be both, then it is known as a bijective function. Let's come back to this question where we are going to learn this question based on the previous knowledge. So what they have said here, show that F mapping n to n in the sense what? Natural number set to a natural number set. So therefore here first we will write down these two things, that is two sets mapping from n to n. Okay, natural number set to a natural number set. So when you come across natural numbers, from where does it begin? 1, 2, 3 and all the way up till infinity. Okay, so natural numbers are said to be these. Now what they are telling us, f of x is equals to 2x. Now how we are going to solve this theoretically is, first we are going to consider f of x1 is equal to f of x2. आम्ही काय म्हणालो इकडं, वी आर गोइंग टेलिंग दॅट दोन्ही एफ ऑफ x1 ला जे व्हॅल्यू आहे ते एफ ऑफ x2 ला बी आहे. म्हणजे सपोज एफ ऑफ x1 इज 1 2 3 4 1 2 3 4. सपोज एफ ऑफ x1 म्हणजे हे बनवून पकडा 1, एफ ऑफ x1 ला इमेज 1 आहे आणि एफ ऑफ x2 ला बी इमेज 1च आहे. ठीक आहे, हे 1 1 झालं काय? नो, दिस इज नॉट 1 1. ओके, बट असं आम्ही मानून चाललोय, वी आर अज्युमिंग दॅट 1 and 1 मॅप्स विथ 1. बट नाउ व्हॉट आय एम गोइंग टू शो इज, हे x1 आणि x2 हे वेगळे वेगळे नंबर नाही आहेत, बल्कि मी चुकून हे 2 ला बी 1 होतं त्याला 2 म्हणून मानून घेतलं. इन द सेन्स व्हॉट, नाउ इफ यू सबस्टिट्यूट f of x is what? 2x. x च्या बदली काय आहे? x1. नो, सो therefore 2x1 is equals to 2x2. इथं x आहे म्हणून x हे आलाय, इथं x1 आहे x1 आला. अंडरस्टँडिंग? So therefore 2 and 2 cancel, x1 is equals to x2. So this is how you solve theoretically. Therefore f is 1 1. Let's solve the second one. Second is what? Onto function. If you want to prove it is onto, you need to check it for all the things. You should check for everything, but you don't want to show it. What they have said, but not onto. You have to show that it is not onto. So now let's check that one number. So f of x 2x, right? f of x is 2x. f of x ला y is equals to 2x म्हणून मानून घेऊ. f of x is nothing but y. y is equals to 2x. So x is equals to what? y by 2. For every x belongs to x, there is number y belonging to capital Y. Suppose y is equals to 1. Suppose y is equals to 1, then x is equals to 1 by 2. बरोबर? But natural number मध्ये 1 by 2 येते काय? Does 1 comes in natural, 1 by 2 come in natural number? No. See, you have a point over here. Understanding? So, but x is equals to 1 by 2 does not belong to natural number. Therefore, f is not onto. So coming on to the next question, as you can see here, show that the function f mapping n to n, what they have given by f of 1 and f of 2, both value is what? 1, and f of x is equals to x minus 1 for every x greater than 2. F is mapping from n to n. Natural number set कुठनं स्टार्ट होत आहे 1 2 3 and till infinity. ओके, त्यानं काय म्हटलं की f of 1 is equals to 1, so f of 2 is also equal to 1. मजाक आहे. सी व्हॉट दे आर टेलिंग इज, जर तुम्ही दोन नॅचरल नंबरचे सेट घ्या आणि इथं 1 2 3 4 5 1 2 3 4 5 हाय, एफ ऑफ 1 ठेवलास की नाही तू फंक्शन मध्ये तर तुझा आन्सर 1 यायला, आणि जर तू एफ 2 ठेवलास तरी आन्सर तुझं 1च यायला. इन द सेन्स व्हॉट, बोथ 1 and 2 हॅव द सेम इमेज 1, therefore not 1 1. क्लियर आहे ना? No doubt only. Since f of 1 is equals to 1 and f of 2 is equals to 1, which implies that 1 and 2 have the same image 1 in the codomain, which implies that f is not 1 1. So what does onto states? Every second element should be occupied. Natural number set है. 1 आणि 2 already occupied है. 2 पासन इकडं occupied नहीं है आणि 3 पासन इकडं अभी occupied नहीं है. But what they have said as, for f of x is equals to x minus 1, x च्या पुढे किती वेळ येत नाही त्याला x minus 1 चं डेफिनेशन दिलेलं आहे. For x greater than 2, for x greater than 2, f of x is what? x minus 1. f of x ला मी y is equals to x minus 1 ने रिप्लेस करो. Now send this 1 to the other side. y plus 1 is equals to x, x plus x is equals to y plus 1 लिखतो. Okay, this is x, this is y. So now y मधलं कुठला भी नंबर उचल पटकन, 1 ला सोड 2. So if you substitute 2, x is equals to 2 plus 1, answer 3. x is equals to next number 3 घाल 4, x is equals to 4 plus 1 5. In the sense what, this goes on continuing, no? Continue हो जाता है. So for every y belongs to y, there is x in the domain such that 2 is mapping with 3. Understanding? असं आता 3 4 ला होता है, 5 goes on. Okay, it goes on. So therefore every element in y has been occupied. Therefore f is onto. So in this sum we are going to study solution. The given function is f mapping r star to r star real numbers set star, where function f of x is equals to 1 by x. We are going to consider f of x is equals to f of y. Now we are going to prove that this, as explained earlier, sum. आता मी काय मानून चला गेलोय की x आणि y दोन वेगळे वेगळे नंबर्स आहेत. These are two different numbers, but at the end we will show it as the same number. f of x is what? 1 by x. इथं x आहे म्हणून x दिसालाय, so x घातलो. इथं y आहे तर काय दिसणार? When you flip it over, so x is equals to y. Therefore f is 1 1. So in order to prove onto, what we are going to consider, since the function is defined on real numbers, we even get fractions as well. For every y belongs to r or r star, there exists y is equals to 1 by x. Okay, or you can even consider this as there is x is equals to 1 by y. So now what is your function? f of x is equals to 1 divided by x, correct? What I have, x is equals to 1 by y I have, so substitute 1 by y here. ठीक है? So what is f of x will become now? x the value का 1 by y है ना, so f of 1 by y also you can consider 1 divided by 1 by y, म्हणजे x the value 1 by y होता, त्याला replace केलं. So this fraction if you convert, this is giving you y, but f of x is equals to y. So therefore when you have this condition, we say f is onto. Check injectivity and surjectivity. It is very simple. Injectivity म्हणजे 1 1 and surjectivity म्हणजे onto. So these are the different names only, 1 1 and onto just. But now we are going to study function is defined from natural numbers to a natural number, correct? So n to n given by f of x is equals to x square. So natural number to natural number, so f of x1 is equals to f of x2 म्हणून मानून घेऊया. Now f of x1 is equals to f of x2. खरं x1 काय है? x1 square is equals to x2 square correct? Square and square eliminate, common I, so x1 is equals to x2, therefore f is 1 1. Simple. Therefore f is 1 1. Now in the second case, what happens? If you want to show onto, you have to show it for every number. No, मला दाखवायचं नसलं तर find one such number. ठीक आहे? So I'll explain you this one in depth. See here, natural number to natural number आहे, म्हणजे 1 2 3 4 1 2 3 4 so on numbers will be there. f of x काय है? x square है, correct? So 1 square, 2 square, 4 square, 16, correct? 3 square, 9. So हिकडनं कंटिन्यू होत आहे, ओके? बट देर आर इन बिटवीन नंबर्स लेफ्ट ओव्हर. 2 आणि 3 चं कुठं आहे? सोड बा. 4 5 6 7 8 ते नंबर्स कुठे आहेत? ओके, इट मीन्स व्हॉट? सम ऑफ द व्हॅल्यूज इन द सेकंड सेट इज लेफ्ट ओव्हर. देन इथं सेकंड सेट मध्ये कोणतर सिंगल असलं तर त्याला 1 1 आम्ही म्हणू शकणार, ऑनटो म्हणू शकणार नाही. सो देअर फॉर नाव x belonging to, sorry, 2 belonging to natural number, there is no element, म्हणजे set y. For 2 belonging to y, there is no number in x such that f of x is equals to 2, correct? F of x is equals to x square. Understanding? Therefore f is not onto.